Hi there, Nikki here, and welcome to a video on simple report generation using Ansible. So in this video, I'm going to take a real-world BGP problem, which is MTU related. So in this lab, I'm going to have an MTU issue, and the BGP peering is not going to form properly. So we're going to report on BGP state to help resolve this issue. I'm going to get into discussing structured versus unstructured data and how you can manage unstructured data. So to date, I've been using Ansible Facts, which returns a certain amount of data on the routers and switches in JSON formatted, structured in a JSON structured format. However, that's only a small subset of the information you need to manage your network. If you want to use show commands and get that in a structured way, then there's two methods I'm going to discuss. One is to parse that CLI, get the information, the exact information that you're looking out of in a particular show command, and create a custom fact using the Ansible set fact module. And then the other way is there's well-known libraries available online, such as Textfsm that Google created, that allows you to pass show commands into a template and it returns structured data. So we'll get into that as well. But firstly, just to have a look at how BGP works out MTU. So my lab here, each router maintains two BGP sessions to the two routers in the core site. So if we just review one of the routers, we can see that currently this site 2 router 2 has got two stable BGP peerings and it's receiving prefixes. So we know that by default BGP uses path MTU Discovery, which is viewable if you do a show run all. It's not in the regular show run. And just include for MTU. You can see that it's enabled by default. So what this means is it sends increasingly larger packets to upstream, and when it exceeds MTU thresholds, it'll get dropped upstream, and the upstream router will return an ICMP error code that allows this router to work out what the optimal MTU setting is. So generally, if you have an eBGP session and there's only two layer 3 routers, you don't have any device in the middle that is going to impact on your MTU, and it will work out the default settings, which is generally 1460. So if we just have a look at show IP BGP pairs and search for max data, you will see here we're working with default values because the 1460 is your Ethernet MTU of 1500 minus 20 for the IP header and 20 for the TCP header. But if we were to tweak the MTU on one of the pairs, so say site 1 router 2 is on 80/2. So if I just go to 80/2 on this router, and 80/2, yeah. And if I just tweak the MTU here to say 1400 bytes, and then go back here and clear that pairing, which is 10.2.0.13. Right, should come straight back up. And then if I run that command again, you'll see that it is reduced by 100 bytes down to 1360. So that just demonstrates how that path MTU discovery works. However, in this instance, I've added a fourth site, and this then demonstrates the issues that you can hit. So if you're running a BGP session over the internet, typically you would have an encrypted tunnel, whether it's just regular IPsec or DMVPN, and then you run BGP over the top of that, and then you can't hit MTU issues if the source BGP router can't receive the ICMP error message back, or in this instance we're going across a layer 2 network. So what I've done here is on site 4 router 1, its primary BGP peering to router 1 in the core site is the same as all the other sites, but its other BGP peering is via a carrier network, which is a layer 2 network. So what I've done on this Ethernet 0/2 is I've created VLAN 100, and that pairs with VLAN 100 on site 1 router 2. And then in the carrier network, I've created a .1Q tunnel with a VLAN 10. So that's what will impact on the MTU, and it's what I've seen recently in a real world situation. But I've also, because my BGP updates are very small in this lab environment, I've also tweaked the MTU right down on this switch so that I will get that failed behavior on site 4 router 1. So when site 4 router 1 now tries to discover the MTU, because this is a layer 2 network, it's not going to respond with a layer 3 ICMP error message. So it will default to the 14, 16 bytes that we seen on site 2, but it's sending packets that are too large, and it gets dropped in the carrier network. And because when BGP sends an update, it at the same time stops sending keep alives, router 2 in site 1 never receives the update, never receives a keep alive, and the whole timer expires and it tears down the session. So if we log into site 4 router 1, we will see show IP BGP summary. We will see that at the moment both pairs are up, but the peer to router 2 is only up for just under 2 minutes. It hasn't received any prefixes, and if we have a look at the logs and just include for BGP, we'll see a lot of adjacency changes. So it's bouncing every 3 minutes, so 1231, 1234 every 3 minutes or so. And also if we have a look at the show IP BGP neighbors and include max data, we can see that it can't detect this change in MTU. So this first line refers to the router, the BGP peering to site 1 router 1, and the second one to router 2. So that's the issue. So in our report, what we would like to include is the max segment size for each BGP session. Also, whether the the state of the BGP session, whether it's in an established state or not, which you get actually from the show IP BGP neighbors command. So you'll have BGP state established, and also how long it's up from up for. So that's also in BGP neighbors, but the way we are going to run this report, we will get it from the BGP summary. So we'll gather all of that information from these show commands, and then eventually we will write it to a CSV file that we can then load up into Excel, and we'll have a report. So moving on to Ansible, the first thing that I'm just going to show is the first command, show IP BGP neighbors and include max data to work out the segment size. And I'm going to register that result in BGP underscore result, and I'll get onto the set facts in just a sec, but I just want to run this to show you what the output looks like. So if I check BGP maximum segment size, so when we run this, we will expect to see a standard out list and a standard out underscore lines list. And if we just compare those two, so you can see that standard out is a single element list, and that single element has got the data for both the peering to site 1 router 1 and the peering to site 1 router 2. So if you wanted to interrogate that further, you would have to split this data somehow. But if we look at standard out lines, you can see that it's a single element list, and inside it has another inner list with 2 elements. So standard out, we would refer to this first square bracket as element 0, so standard out underscore lines dot 0. And then inside that we've got another, an inner dot 0 and a dot 1, where dot 0 is the router 1 pairing and dot 1 is the router 2 pairing. So we can now look at these 2 elements individually and split these, and we can see that if we use the space as the split, that we could split this element further, and then we can notice that the value that we're looking at, the 1460, is 0, 1, 2, 3, 4, 5th element in this information here. So what we're actually going to do is we're going to use a Python split module that says take each of these lines, split it via the space, and pass the result into a new list, which is our custom fact. And the 5th element in that new list will be our number for the maximum segment size that we're looking at. So if we go back to our YAML file, you can see how we're doing that with the set fact module. So I'm creating 2 custom facts: maximum segment size for the peering to site 1 router 1 and to site 1 router 2. So I take the BGP result standard out underscore lines. I know that element 0 and inner list element 0 is the peering to router 1, and I split that via the space. So the result of this split gets passed into this new variable, which is a simple list. And I do the same for the second pairing, and I just change the inner element to 1. And then we can, if I just comment this one out, and let's display the result of element 5 of this new list, and we should just get our maximum segment size. Oh, I've got an indentation error here. So we run the show IPBGP neighbors command again, and we set our fact. And now we can see for each router we've got the maximum segment size. So for all of the routers, with the exception of the one that we changed, which was site 2 router 2, it's 1416, but then that router is the 1360 because we reduced the MTU by 100. So that's our expected result. So this variable now, maximum segment size site 1, router 2 and 1, is a variable that we could use in a Jinja template like we would with an Ansible fact for our reporting. So that's the first key piece of information we've now we now have created in a structured format for our report. However, it's not always that easy with the show commands. If we were to add a new show command, say our show IP BGP summary, and if we just bring the BGP result back in and look at the results of show IP BGP summary, and just to keep it tidy, I'll hash these 2 out. So what we're going to do here is, because we've added a second command into our iOS commands, BGP result is going to be a deeper structure. So standard out lines will 0, like we done in our custom fact, will still refer to show IP BGP neighbors max data. But now we will have a second element, which is standard out underscore lines dot one, which refers to the show IP BGP summary. So let's run that and have a look. And the good thing about in iOS command about using the dash, which are extra commands, is you can see that it's all run as one single task. I've got a called show IP BGP neighbors. I'll just go back. I've got the task called show IP BGP neighbors, but it's actually running two commands in that single task. If you split it into multiple tasks, you've got a lot more output, so it's just a tidier way of doing it. So if we just look at what we've received this time, so we've got standard out underscore lines, element 0 is as before, and now we've got an element 1, and that's our show IP BGP neighbor. So the information that we're interested in this output is the uptime. So that's deep inside this output, and if you wanted to just take the time from this output and pass it into a custom fact, Ansible has the capability to run regular expressions across it, and it can be as complicated as you want it to be. However, I would always look to see is there a simpler way of doing it, and has this been done before? Usually the answer is yes, and in this instance Google created a library called Textfsm that allows us to pass show commands into templates and have structured data returned. So what I'm going to do is I'm going to use Google's Textfsm, but there's another company, network automation company called Network to Code, and they've created templates for Cisco iOS, NXOS, and other vendors to work with Textfsm. So what we can do is we can run our show IP BGP summary command and pass it through Network to Code's Textfsm template, and it will return structured data for us. And that's a far easier way to get our structured data than to be manipulating quite complex regular expressions. So if we move on to my next playbook, I can show you how that works. So in this, I've got the three commands that we discussed earlier: show IP BGP summary, neighbors, and neighbors to include max data, and that's element 0, 1, and 2 in my output here. And I'm creating a number of custom facts. So down the bottom, I have my maximum segment size facts as before. There isn't an NTC template to get just this information, or I couldn't find a command that returned the MTU maximum segment size. So I've just done that via my Python split method as before, and that's element 2 in the list. And then I've got BGP summary, and which is element 0. I parse that through to this new module here, parse underscore CLI Textfsm, and with this module I call the NTC template Cisco iOS show IP BGP summary.textfsm, and that's stored in my playbook directory in the NTC templates directory. So you have to clone that down from GitHub, and I'll show you that in a second. And I do the exact same with the show IP BGP neighbors using another template. And then I use my debugs to display all of the output from the above. So if you want to use Textfsm, it's not built into Python. So the command to install it is pip3 install Textfsm. So you just run that, it'll automatically download it for you. I've already done that. And if I just go back to my history, I'll probably still have the git clone in there. Yeah. So to get the NTC templates, you do a git clone to https github.com/network-to-code/ntc templates.git. That will create an NTC templates directory in my playbook directory. And if you go in there and to the subfolder templates, you will see that there's a long list of templates that that Network to Code have created for us for lots of different vendors and products. And you'll see on the Cisco iOS the two that we are interested in, show IP BGP neighbors and show IP BGP summaries there. But there's lots others that gives you structured data that is very useful for managing your network, so definitely worth checking out. So if we just go back up and run this playbook, so that's 2, and we're going to create our 4 custom facts this time using Python split and Textfsm. So we let this run. Again, I'm running 3 commands this time in one task, so it's a tidier output. And now I can begin to see the structured data that Textfsm with NTC templates is returning to us. So down the bottom I have my maximum segment size custom fact that I created with Python split, and then up here you can see BGP neighbor turns structured data in a list of dictionaries. So for instance, we've got BGP state, which we can refer to in our templates, and you'll notice that from the BGP neighbor command, it didn't return the uptime, so I needed to use the BGP summary command for that. And if we go up and have a look at BGP summary, you can see that it returns up, down, and I have the timer there. And it also returns the BGP neighbor. So I can create a report that says for, I don't know, site 2, router 1, it's BGP neighbor 10.2.0.1 is in an established state, it's up for this long, and this is its maximum segment size. So that's the information that I'm going to put into the report. And then when we build that report, we can see is there any BGP peering that is that has a low uptime, and then look at them closer to see if it's got this issue. So the first template, I'm going to just do it for all of my routers, all of my CE routers, and record all of the information, whether it's up for a long time or a short time. And then in a second template, I'm going to do a simple if then else check to say if the uptime is less than 5 minutes, just report on that. So we can just zoom into the BGP pairings that we are suspicious about. So if I just look at my templates, what I've done is, if the first one, I'm just going to do all BGP pairs. So it's quite simply, I'm grabbing inventory underscore hostname. I'm separating all of my variables via a comma, so they're comma separated, so we can load it up into Excel. So inventory underscore hostname BGP summary element 0 refers to each CE router's BGP pairing to core site router 1. So I grab the BGP neighbor IP, and then from BGP summary element 0, I grab the timer, the up down dictionary key value pair, and then BGP neighbor element 0, I grab the BGP state so I can see if it's established, idle, or whatever, and then my custom maximum segment size. So I'll have the value of the maximum segment size, so we can easily see if there's any sites that has a lower than expected value, because if you had a value too low, it could actually impact on throughput as well. So it's worth considering that too. And then I repeat it for the second BGP pairing, so it's just element 1 for all of these ones here. And if I go back to my playbook. I can, just to reduce the noise, I will comment out each of these. And let's then use the template module to build our templates. And then I'm using this assemble module, which I'll just describe in a sec. So the template module takes my Jinja file, all BGP pairs, and for each router, it will generate output, and it will store it in playbook directory subdirectory output. It'll put the router host name in front of the file it creates, -bgp.out. So it's going to create a file for each router, and then the assemble module simply assembles all of the files in that directory into one file. So I'll have one file in my playbook directory called bgp-report.csv. Firstly, in that output directory, I've started off with this simple header file, and I've just named it with AAA at the beginning, so it's always the first file that's assembled, and that's just so that we'll have a header in our generated CSV file. So when we open it up in Excel, we'll just have the header router BGP pair IP uptime state and maximum segment size. So that's quite simple. And if I just run that now, hopefully I haven't got an indentation error. Yes, I do. Okay, so yeah, one in. Might be this. Right, I'm just going to pause the video for a sec while I work out why this is happening. Okay, I think I've sorted that out. It was a combination of the dash template in the wrong position and the source and destination having to be indented in, I believe. So hopefully this time I'll get a better result. Yep. So we gather our three commands, we set our facts, and then we generate our output. So the template runs, and then we assemble. So now we should have a report.csv file. So it's bgp report.csv, and that looks like this. So for each router, we have all the information we want, all the timers we want, and the maximum segment size. So if we were to go back to the Eve topology and connect into our Linux box, on here I have installed LibreOffice Calc, which is like Excel, and then we should be able to open that file up. So that would be this one. And just say OK. And now we have all our information nicely in Excel, so you can use whatever Excel functions that you want. If you wanted to find the site for router 1 pairing to to site 1 router 2, which has a very low BGP timer. So that's one way to do it, but I also I have another template. First of all, before I run it, I would have to remove all of my .out files here because I'm going to rerun it. Just leave the header, and let's just remove the CSV file as well. And I've got another Ginger file failing BGP pairs. So in this second report, I just want the ones that are suspicious, the ones with very low BGP uptimes. So if I just log into that, it's just a simple if statement. So if you remember in the structured data, the up-down variable was the timer, and element 0 is for the primary peering to router 1, and element 1 is for the secondary peering to the central site router 2. And I'm just doing a simple, if that timer is less than 5 minutes, then give me the output, otherwise just skip. So if we just run that one, we first have to amend our template in here to change this to failing, and then run that. So if you are working with a large number of sites, then it might make sense just to get a report on the failing ones. And we run this again, and we have a look at what we end up with. So set our facts, run our template, and assemble. So in this instance, if we look at our output file, we should have we still have a file for each router, but if we look at our report, CSV, I think it's BGP report, isn't it? BGP, yeah. We have in this instance we've only got 3 lines, and it's actually putting lines in for everyone it's skipped as well, but we can see that there's some that are why is this one appearing? Okay, so we do have unexpected information. This one I was only expecting this one, because that's the only one that's less than 5. Let me see what the maybe I had a you see in the second one I've got 55. I was testing it, so that's why I'm getting that extra data. So I just changed that back to 5 minutes, and you can actually get rid of these spaces. I might do this in another video. It's called white space handling, where in your Jinja template you can put a dash in certain spaces, and it'll delete those in certain locations, and it'll delete those spaces. But if I just clear down this directory again, and I'll just show you briefly what I mean by white space management. If we were to put a dash in here, it will delete the line, the space that comes after it if it's just a space. And if you put one at the beginning of the percentage, it deletes a preceding space. You got to be careful with that. Sometimes it can combine 2 lines together unintentionally. So I'm just going to ignore that for now, but it might be a topic for another video. And this time, if we run it again, I should just get the output for the failing one, which is the site 4 router 1. So we run our commands, set our facts, and generate our report. And this time we should have just router 4 in our output. And if we go back, log in again, and open up our BGP report. And you can see that now we just have our failing one. And obviously with white space management, this will be a bit neater as well. But that concludes the video. It's very useful, that network to code templates, if you want to get information from your network. There's lots of commands in there, and but sometimes you will have to use Python split and maybe even regular expressions if there isn't a template for it. But I hope that helps with creating simple reports using Ansible. Thank you very much.